Are we ready to go? We're ready to go. I'm getting thumbs up from Mark. Switching. All right. Good evening. Thanks for coming to Resource Stage tonight. We've already had a bit of a conversation before we started streaming. Thanks for coming. We're happy to have you here. It is a really nice night out outside, so I appreciate you coming in and sitting in this dark room with us. And tonight we are going to be talking about theatrical lighting fixtures. If you saw the posts that we made online about tonight, you'll know that I said in that little video that this light over here, the one on the far end there, is a fixture that I used on the very first show that I ever did. And that was sometime in, I think it was like 1991. I was 15 or 16 years old. And I was helping out with this group that was touring around into schools and churches doing shows. And that was an old light back then. and it's a tad awful, to be perfectly honest, because it's really hard, and especially when you compare it to how new fixtures work. And so every once in a while we think, hey, you know what? It's a good idea to kind of take a step back and look at where have things come to with theatrical lighting, and where are we at right now, and how do the fixtures that we work with today compare to the fixtures that we used to use. And sometimes in some of our community theaters and high schools, we still use those fixtures. In fact, actually, I was out at what is now referred to as First Ontario Concert Hall, which also, many people still know that as Hamilton Place, downtown Hamilton. And they have fixtures that are almost as old as that light, still being used on a daily basis. And they still light shows with them pretty regularly. That and park hands. There's a lot of park hands on that stage still. It's crazy. But tonight we're going to kind of talk through some of these different things, and we're going to talk a little bit about control, and we're going to talk a little bit about the fixtures themselves, and I'm hoping that barn door doesn't fall off that fixture. So first, to start off, and certainly if you've got any questions, or if you're online and you're watching live, if you have any questions, then feel free to go ahead and ask in the chat, and we will try to answer those questions. So first of all, what is a stage light? We need to kind of start here. I've used this slide a number of times before because I think that this is a good way to kind of sum up what I think of with stage lighting and how it's what are the things that kind of make a stage light. And first of all, click again. There we go. First of all, it needs to be predictable. You know, when you're doing a show and you expect that things are going to continue to happen, and that the show is going to continue to happen, and everybody's going to hit their cues and so on and so forth, then the lighting has to be just as predictable as the talent, and just as predictable as the sound effects and everything else, and where the sets are going to go. I mean, we spike pieces of furniture on stage so they land in the same spot, and hopefully the lights act exactly the same way. If a light fixture is not predictable, it's not worth using. And so that immediately eliminates some of the DJ product out there. It immediately eliminates some of the pieces that are, just a little more flaky. Controllable might mean that all we need to be able to do is turn it on and off. That could be just a relay, or that might be something else, but controllable means that we have to be able to control it in such a way. Okay? And again, like control, I've seen control that basically means you can turn it on and off with a power bar. Efficient. This is not necessarily a must-have, but the entire industry has been pushing closer and closer to efficiency for the last 30, almost 35 years. Everybody's been pushing to how do we become more efficient, and we're going to talk about that with a little bit when we talk about the Source 4 and then where we're going with LED fixtures. And reliable. And reliable kind of lands in the same thing as predictable, except that I think that it's a good point that a fixture needs to be reliable because these days fixtures cost a lot of money. And so you want to know that that thing's going to last you for a long time. Does that make sense? All right, sounds good. So let's start off with some pretty old fixtures, because this is a really good way to kind of explain how some of these work. This light right here that we have a picture of, which actually I found this picture online by Paul Collins. This is a great picture. I like this one a lot because it's really good at kind of showing how all of these different pieces inside an old school ellipsoidal, or often referred to as a LECO, how that works. It's similar to the fixture that we have over here, this old one, but there's one distinct difference. Anybody? What's the distinct difference between the one in the picture and the one that's sitting over there on the side? The lamp, yeah. The lamp on that one, and I've got a picture, if you can't see it online, I've got this picture here that kind of shows a little bit closer to how that light works. The lamp is coming in on an angle, often referred to as an old dog leg fixture because it's got that dog leg piece. Any of you guys have those in your spaces that you're working in? Do you have some of these? Do you? Awesome. You can see in the picture there that bulb would have been very big. It has a large envelope in the bulb, or the bulb part of the bulb is bigger. We don't sell bulbs like that anymore of that size. Now they're much thinner and they're a much smaller piece, but they still have to have that long envelope so that it gets the light into the right spot. We're going to come back to that in a second. So if we take a look at this fixture, we have the power cord, the lamp housing in the back with a socket, the lamp that fits in through here, and then in these older fixtures, these were typically an aluminum or a tin reflector, and then the light would be all focused to come through the gate, so right at the spot where both the shutters are. You can see it says shutter there, as well as the template slot, also referred to as the gobo slot. Thank you, Bob. And so you would stick the gobo in there, or you can adjust the shutters right there, right at the point where all of the light is being focused together. And then in this case, we typically would have had two lenses, and then you have this knob at the top, which would allow you to loosen it off and slide the barrel in and out to focus the light. The problems with this are many. Partly because these fixtures get very, very hot. They're a cast fixture, they get crazy hot, and the shutters get hot and sticky and hard to keep to move in and out. Sometimes they would, in some of the maybe newer fixtures of this style, they would fall right out. In an effort to try to make them easier, they actually fell out. I saw a picture online yesterday of somebody selling kind of a newer version of this. And when I say newer, I mean from the mid-90s. And they were looking to sell this fixture on Facebook Marketplace. And they have the fixture, and they have a C-clamp, and they have a gel frame, and then they have the two shutter flags are sitting beside the fixture, which is exactly the way they often ended up because those silly things would fall out way too easily. But the other piece was, and you can see it on this fixture, maybe once we're done we can take a look at it, but because of the way that lens tube would fit inside, then if it sat in for a long time, then it would expand, and then you couldn't slide it in and out very well. And I mean, I may have hit a light or two with a hammer once or twice, trying to get that thing to actually move. So this whole concept of a light was pretty standard, and we saw it all over the place. And we still do see those, as many of you pointed out, that in still many theater spaces. This one is very similar. The difference is how the light comes is hitting the reflectors, and different manufacturers had different ideas as to how to deal with getting light and getting the filament in exactly the right spot to get the most amount of light coming out the front end. Some of these designs are very, very old, pushing 100 years old at this point. It's kind of crazy, really. This next picture here kind of gives you a bit of an idea as to what the theory is here. So the filament being right in the center of the reflector, it's kind of like physics class from school, and all of the light being reflected so that it lands right here at the gate, and then if that's the focal point, then it is coming out, hitting the lenses, and those two lenses together are going to create the beam spread that's coming out the front end. And depending on what those lenses are and what the spacing of those lenses are is going to determine the beam spread that you have coming out the front. Back in the day, we had lots of fixtures that were referred to as 6x9s or 6x12s, that kind of thing, right? And that would be a reference to the size of the lens and then the spacing between those lenses. Okay? So that was or is still a very traditional way of theatrical fixtures being put together. So that's an ellipsoidal, or again, the term that often gets used is LECO. LECO is lots of people know this, but maybe not. LECO is a brand name. It was a brand name from Strand Century, and we don't have any LECOs anymore. They don't exist for the most part, but it is still a terminology that gets used just like Band-Aid or Kleenex. Okay? So let's talk about this fixture, one that I forgot to pull out until 5 minutes ago. This is a very traditional Fresnel. Okay? And I'm sure that everybody here has used a Fresnel before at some point in time. The Fresnel is pretty simple. It's changed many times throughout the years, but this is kind of a fun version of it. This one's actually got a broken handle on the back end. But the bulb being inside the fixture here, sitting on a plate with a reflector in the back, and you can hear it's making lots of noise. This then slides forward and back to change the beam spread. So where we could not, in a traditional LECO or ellipsoidal, an axial fixture like that, we couldn't change the size of the beam. One of the things that's cool about a Fresnel is that you can change the size of the beam by moving the lamp closer to the lens. These are referred to as Fresnels because of the Fresnel lens that's on the front of them. And the Fresnel lens is pretty standard. I remember at one point in time, a number of years ago, that it came out that there was really only like 3 places in the world that actually made Fresnel lenses for the theater world, because there just wasn't that much demand for many companies to be making them. The biggest changes in this style of fixture for a number of years was heat dissipation, and was really all about the mechanics of how would you move that light forward and back. And so this old one so this is actually a Century fixture, as opposed to a Strand Century fixture when Strand bought Century. This knob on the bottom here, when you rotate it, and it's actually broken, so it's actually cutting into my finger. As you rotate that, then that moves that lamp base forward and back, closer and further away from the Fresnel lens. Okay, and you can see that in the picture there. And one of the things that is pretty interesting about this, again, I said that the real changes in a fixture like this were really just about how you manipulated it and heat dissipation. For the most part, these fixtures in a 6-inch Fresnel, which is very traditional for community theater and church applications and school applications, the bulbs are exactly the same as they were, going back 30 years ago. Now, they're not the big bulb ones that would have been available when that fixture was brand new, but there's still a 500 watt BTL, a 750 BTN, and a 1000 watt BTR. And each of those bulbs is pretty standard, and still we have them in stock. I think we sold some yesterday, sort of a thing. Okay. It's important to note that the Fresnel lens is a convex lens that's essentially cut up. And a lot of people have heard this before, that a Fresnel lens, the most famous Fresnel lenses, are often seen on lighthouses. So if you ever get a chance to go and visit a lighthouse, go and climb up a lighthouse somewhere like Point Clark is a great example. You can go up into the lighthouse and stand right beside there, or there's lots of them, of course, on the coast. And you can go up and you can take a look at it, and that Fresnel lens, it's exactly the same. It might be elongated a little bit, might be a little bit different this way or that, but the same concept. This idea that they're cutting out all this extra glass to make it more efficient. That term efficiency comes up over and over again. Okay? So that is the Fresnel. In about 1991, 92, I think it is, ETC, Electronic Theaters Controls, a company that specialized at the time in control devices, so lighting control consoles. That's how they started. Fred Foster and his brother started that company in their garage, and they were building lighting consoles in 1975, 1974, I think it is, something like that. They were building consoles. They came out at the LDI show in, I want to say it was 92. They introduced a new bulb that somebody else developed, that they worked with them on. They introduced that new bulb with a new fixture. And that new fixture was the Source 4. The ETC Source 4 is by far the biggest change in the industry that had happened up to that point in time. Strand and some other manufacturers, Colortran, were coming out with new fixtures at that time, but they were all built on that older technology. They were built on exactly the same designs that we're talking about that I've already shown you, only they might have been, they had more of a tin sort of a makeup of them. They were less expensive to make. They were a little bit more efficient on heat, that kind of thing, but they weren't like this. This was a cast fixture that used a 575 watt bulb and got an output that was over that of a regular 750, close to that of a 1,000 watt bulb. Instead of using an aluminum or a tin reflector, they were now going to a glass reflector that had a dichroic coating on it. And so that changed a lot of things. This is a Source 4 that's a modern Source 4. I mean, there isn't a whole lot of differences from the one that was introduced back then to this one. The burner assembly on the back end of this fixture has changed. The lens tube on this one has changed, but we'll talk about that in a couple of minutes. But for the most part, it's the same fixture. So it has a glass dichroic reflector in the back. The Source 4 bulb, which is an HPL bulb, fits in the back end, and then there's a good size heatsink in the back end. Again, efficiency, right, and dealing with heat, getting all that heat out the back. And then they introduced a couple of interesting features at that time. One of which is shutters that don't come out. You can't get those out without really working at it. Another one is that you have the ability that if you turn this knob back here, then you can rotate the barrel 45 degrees. And that was a pretty big deal at the time. They also standardized what sort of gobo holders they could take. They also did some things about how the lensing worked. So we talked earlier on about things like the 6x9 and a 6x12, right? There were some manufacturers like Strand that were starting to look at that kind of thing and say, well, hold on a second. If we said this kind of lens, well, that's closer to 30 degrees. That's easier to talk about. That's easier to tell new people coming into the industry that that's about 30 degrees, 40 degrees, 50 degrees, 20 degrees. Well, ETC said, well, actually, those lenses are closer to 19, 26, 36, 50. So we're going to use that term that is going to help the newer crowd who's coming in to understand what light is coming out of there, but also be a nod to what the other fixtures were, what the old fixtures were, and the actual beam spreads that were coming out of them. So they did a lot of things to try to encourage people. The reason this fixture was referred to as the Source 4 is that if we go back to that slide for a second, if you take a look at the bulb, if you can see there, it actually has, right in here, the equivalent of 4 filaments all stuffed within that one element. So those 4, there was 4 sources, so they called it source 4. That's really what it came down to. So they're really naming the fixture after the bulb. And, of course, they had a copyright on that. So nobody else could make this. That copyright has now run out, but really nobody else is building that kind of thing for the most part because so many people have moved on to LED, so it's actually worked out not too bad. The timing was not bad for them. So maybe we'll take a quick second here and just quickly look at this fixture just so we've got it as a reference. So we shifted things around in the room this week so that everybody could kind of see both sides here. I'm not sure exactly how this is going to play out on camera, but we'll have to see. So again, glass reflector. If you take a look at, we're not going to plug it in right now, but if you take a look at that old fixture, you would never be able to get the sharp edges that we can with this fixture, with that old light. It didn't matter how hard you hit it with the mallet. You couldn't get that focus to be what it is. You also couldn't get the sharp edges that you could with this, right? Again, this was a revolutionary fixture because it did all of these different things. Now, if you take a look at this, it's pretty easy to see here. I'm not sure if it really reads well on video, but you can see that 2 of the edges here. Now, again, understanding that we're shooting on a bit of an angle, so we need to kind of forgive that. But 2 of the edges there are fairly tight, but 2 of the edges are a little bit softer. And that's because we've got 4 different planes that are just out from each other, just a hair. So we're never going to be able to focus perfect on all of them. We can adjust it a little bit one way or the other and kind of split the difference, but we're never going to get it 100% perfect. When the first fixture came out, it was designed for a 575 watt bulb, and that's what was available. And it wasn't until a little bit later that they came out with a different burner assembly on the back end, which thankfully had a handle so that you could focus the fixture by holding onto the handle that was plastic instead of, or I'm sure I'm supposed to call this composite to make it sound more expensive and more important. But a plastic handle on the back, so I'm not going to burn my fingers when I'm touching the back. And at that point, then they changed the type of paint that they were using, and then you could put a 750 watt bulb in it. Today, we have options that are 375 watts, 575, and 750 in an HPL. Kind of a side note about HPL bulbs. If you are going to call up and order bulbs from Horizon for your Source 4s or for your Source 4 Juniors or your Source 4 PARs or Source 4 Parnells or any of those fixtures that from ETC that use those bulbs, you want to keep in mind a couple of things. Not all HPL 575s are created equal. There are some nuances. So for instance, if you purchase an HPL 575 120 volt bulb that is standard life, then that's going to last you for about 300 hours. And at 120 volts, then it's going to be great for our power grid here in Ontario. If you purchase the same bulb, but it's the 115 volt version, it's going to burn brighter, and it's going to burn out faster because you're giving more voltage to that bulb. And you may, if you are building out your theater rig or your church lighting system or your school, and you are lighting everything up and you've got that one bulb that's a 115 volt and the other one's 120 volt, then it's going to stand out. In fact, it's probably going to look a little bit blue compared to the other ones because the 115 volt one is being pushed harder. Does that make sense? Okay. So sometimes people will have a bunch of lights and they say, I just bought all brand new light bulbs. And you can say, well, yeah, but in the middle of that box somewhere, you ended up with one extra that's wrong. The same thing goes that you can buy a 575 in a long life in either 115 or 120. So again, you want to take a look at that. If you take a long life bulb and a regular life bulb and you put them side by side, the long life bulb is typically not quite as bright. Okay, so just keep that in mind. All right, so that's the source for the most part. And we continue to, lots of people say, you must not sell that many conventional fixtures anymore because you must sell only LED, and that's not actually true. We still do sell these fixtures. We don't sell nearly as many of them, but we certainly do still sell these. So then, somewhere along the way, a few years ago, this happened. And I'm using ETC tonight because, one, we have these fixtures, but they also were a leading brand in many of these changes in the industry. And they came out with fixtures like the Source 4 LED fixture, the original one, which actually the 5 fixtures at the above your head here that are lighting me are actually all Source 4 Series 1s. And when those fixtures came out, that was a big deal. That was a really big deal. They're not as bright as that, but they have pretty good color, and they work pretty well. And they're certainly much more efficient than a 575 watt bulb. I want to say those are about 100 watts a piece, something like that. Okay? So they came out with that, and then they continued to roll out additional fixtures. So let's stop there for a second and talk about some other, how we got to this point with LEDs. LED technology has obviously been around for a long time. It's been a very, very long time that, LEDs were on little video game things, or they're on the clock for your VCR or your microwave, that kind of thing. I mean, that's been around for a long, long time. And then they started to show up on the back of trucks, right? Brake lights, that kind of thing, maybe street lights occasionally, that kind of stuff. That sort of thing where it didn't really matter what the color was. We just needed something that was going to be efficient, was going to last a long time. And so there was lots of that. And then we started to see theatrical manufacturers or fixture manufacturers who specialized in performance start to take those little LEDs that would traditionally show up in, again, a stop sign or a brake light, and they would start to put those together to create a light that you could use on stage. They're not really great. They often got referred to as the jelly bean fixtures because they have all these little jelly beans on them. You could run your hands over them and they felt weird. And they didn't really have a whole lot of output because those LEDs were not designed to throw any distance. Those LEDs were really designed so that you could see it from afar and so that it would be bright. You're looking towards it and the light is there, not the light is lighting something up, right? If it's a stop sign, if it's a brake light, it's not supposed to be lighting anything up. It's supposed to be there as an indication, right? There was also no lensing behind them. So what came out is what came out. The color mixing between them wasn't awesome because there was very little control over how bright of a blue LED is in there and how bright of a red LED is in there. And so sometimes some manufacturers would try to get smart and say, well, we're going to put more reds in there than we are of greens because the green is really bright and that kind of thing to try to figure it out. At this point in time, we're going to say, quote unquote, reputable theatrical lighting manufacturers were standing back saying, nope, we're not ready for this. And some of us who sold these fixtures said, nope, we're not selling this because it's just not really helping us. It's not great. The other thing is that LEDs are really bad for heat. And, we often talk about efficiency, right? And about how hot these older fixtures get. And they get really hot. But LEDs, once you start getting past like 25 degrees Celsius at the board, their intensity starts to go down. If you ever notice that LED lights on the back of that truck that you're coming up behind looks really, really, really bright in January, it could be because, there's icicles in the air and that kind of stuff, but they actually are brighter. When it's cold, they are actually brighter. And it's interesting because I've seen specification paperwork from different manufacturers where the number of fans that are in a product has a direct impact on how bright that fixture is. So you could say this fixture has a 3-watt LED and this fixture has maybe a 5-watt LED, but the one that has better cooling could actually have more lumen output. I'm jumping ahead here, but that kind of thing is true. That's part of the reason that you can't really judge an LED fixture based on its wattage. Okay? So, as things progressed, we saw not only these fixtures here, but we saw bars like this. Then we saw some fixtures like these two. This company here, which this fixture here, I have lost count as to how many different brand names I've seen on this fixture because it was built in Asia and then just rebranded multiple times with all kinds of different names on it. And this would have been a red, green, blue, and white LED. You can see those white LEDs in there in an effort to try to get as close to a traditional theatrical sort of a bulb or to a par can bulb, which usually comes in as a white somewhere around 3,000 to 3,500 Kelvin. And of course, the output, as we all know now in retrospect, the output of a lot of those things was purple because the red, green, and blue did not mix to make a really nice white. Then there were these fixtures, and these fixtures were incredibly, incredibly successful. This is a picture of a Color Kinetics Color Blast, and there was a number of knockoffs of this that again came out of Asian manufacturers, and lots of these things. They were rated for outdoors, but they were also used on lots of indoor applications as well, and all over the place. But one of the things you'd run into with a fixture like this, and these, again, we have, actually we don't have any of that kind of fixture here tonight, but a fixture like that, you'd put your hand in front of it and you get these rainbow shadows. Maybe you didn't care so much if you were doing rock and roll. Certainly you did not care if you were a DJ and you were just having a good time. And nobody really cared. But if you were doing theater, and as somebody walked across the stage and it's supposed to be a nice white light, and now you've got this weird rainbow shadow across the stage, lots of lighting designers just said no. So at this point, we need to take a quick detour before we talk about these fixtures. We need to have a really, really quick refresher on DMX. Ready for this? Really quick? Peter, you're good? All right, let's go. So DMX 512, it was standardized in 1986. I always think of it as 1991 because I think there was a lot of acceptance by that point in time in the early 90s. Digital multiplex DMX. There are, on a DMX cable, like, say, this one, there are 512 channels of information being sent down that cable at one given time. 512 channels. So if you had dimming, that would have been 512 dimmers that you could control. And each one of those channels holds a value between 0 and 100%. And those of you who've seen me talk about DMX and fixtures and this kind of stuff know what the next line is. That is, no, it's not actually 0 to 100%. It's actually 0 to 255. So it's 256 steps between 0 and 255, 0 being a step. Okay? So, yes, 256 steps. That means that we have an 8-bit resolution per channel. So channel 1 has an 8-bit resolution, channel 2 does, channel 14 does, channel 112 does. Each one of those channels can have a value between 0 and 255. or if it's easier for you, to 0 and 100%. Okay? Really quick numbers here. Really quick numbers. 0 equals 0. 50% equals 128. And 100% equals 255. Somebody needs to change that slide. So I'm going to give you a really quick example as to how this plays out with LED fixtures. So this console here, I'm not sure, I know Bob Hume has seen one of these before, but I'm not sure if everybody else has seen one of these. This is an old console. This is a console that used to sell a very, very long time ago, and it still works. This is a Leprechaun LP624 that you can pretty much, this is like the SM58 of lighting consoles. You can drop this off the back of your truck and it'll continue to work. Pretty much guaranteed. I've seen it happen. fall off the back. Worst thing that could happen to this is you might have to replace the power supply. But other than that, the thing they're built like a brick. So a simple LED fixture. Let me just bounce back to a couple of pieces here. These LED fixtures here, these simple lights, would be like the color kinetics fixture over here in the corner. That would be red, green, and blue. 3 channels. Red, green, blue. This fixture here would be red, green, blue, white. Very, very simple. Okay? Let's bounce back to where I was. So if a simple fixture is red, green, and blue, then we can lay out on a simple lighting console red, green, blue, and control that fixture with just those individual channels. So I am actually going to grab this light right here. This is a fixture that was loaned to us by our Chauvet rep. This is the Chauvet thing. I'm going to forget what it's called. There it is. It's the Eve P160 RGBW. Anybody want to guess as to what colors it's got? Thank you very much. Yes, red, green, blue, white. That's exactly it. So let's take a quick look at this one. So this fixture is addressed as a starting channel of channel 13. So that means that channel 13 on our console here is going to be the first channel that is going to control that light. And this light, they've given us a little bit more control in its current setup. So the way that is right now, let's just bounce to this. This gives you a little bit more information. So the way that this fixture is set up, channel 1, hold on a second, I'm on the wrong one. There we go. This is the way it's set up right now. This fixture is set up in 6-channel mode. So the first channel is dimmer, the second channel is red, then green, then blue, then white, and then strobe. Okay? So if I go up to this fixture and its address is channel 13, if I push up channel 13, what did it do? Nothing. That's because I still have red, green, blue, and white are still down. So if I bring up the red, then I should start to see some red show up behind me here, right? If I bring up the green, okay, the blue, and the white. Am I getting anything? Yes, I am. Great. And then, of course, I can color mix these to get whatever kind of color it is that I'm looking for. And this is actually, it's really simple. I am using 5 channels, 6 channels on this console to be able to control one light. This is a 24-channel console. If I was running conventional fixtures, then I would have been able to run 24 fixtures, and now I can control 4. It's not really great, right? Just so that we're on the same page, I can adjust these to get kind of whatever color I want. I should point out, in all fairness to this fixture, the resolution of this console, being an older console, doesn't read very well. The DMX output of this isn't best. It's designed for dimmers, not for LED fixtures. So therefore, the little bit of bouncing that we're seeing as I move it, you can see a little bit of flicker in the dimming. That is not a reflection on the fixture itself. We actually kind of like the dimming in this fixture. It works out pretty well if it is on a better console. And then I haven't moved it yet, but channel 18 becomes a strobe channel and allows you to strobe it. Okay? So that is, that's that fixture. Does that make any sense? Okay? Now, really quickly, why do we like this fixture? I'm going to turn it down a tad. Why do we like this fixture? Well, it's very compact. The design of this fixture is that the whole fixture is a bit of a heat sink. So it means that it's good for heat dissipation and it's not noisy at all. It's pretty quiet. The other thing, and I'm going to need to use my incorrectly sized barn door, but what we can do with this, if I do bring up the intensity a bit. Oh, and I should say that if I work hard enough at it, I can actually get a reasonable white out of it. But I can put a barn door on this fixture and actually barn door it to be half decent. Again, this barn door is not the right barn door, but that gives you an idea. Okay? So it's a pretty good fixture. One of the other things to note about this light, though, is that it's very wide. It's very, very wide. And we're going to take a look at this fixture over here in a couple of minutes, and you'll see what the difference is compared to that. And I know, like, at Ingersoll, you guys have lots of color source or no, you don't have color source. You got the Colorados, but it's a similar sort of concept. Okay? All right. So I'm going to drop those down.
Carl?
Yes.
That Chauvet fixture there, can you use the barn door because it's got a point source instead of...
No, that's a really good question. So Bob's asking, can we use the barn door with this fixture because it's a point source? So yeah, thank you. This fixture is what's referred to as a cob fixture. So that is, and here we go again because I can't remember. What does the C stand for again? Chip. There we go. I always remember after a second. Chip on board is cob. And that means that there is one LED in the back end of this. Now, it's actually, in this case, it's 4 LEDs in the back end of this with a reflector or with a lens. And then there is a homogenized lens on the front of it. And when you purchase this, you can actually get multiples of these. This is actually, I lied, it's not just 4, it's actually quite a few of them. But the lenses that come with it, then you can snap that on there and it will give you more like a Fresnel. So then you can use a barn door. Okay? And it's a pretty cool piece. It does come with different lenses for a couple of different beam spreads. This one's lens number 2. I don't know what that beam spread is. I can tell you it's wide. We like this fixture for applications like, maybe in a space with a ceiling a little bit lower than this, where you are just trying to wash a fair amount of area. One of the things to keep in mind, and we are going to be talking about this a bit later, but one of the things to keep in mind is that the intensity of this fixture in a specification sheet, in a cut sheet, is going to look different than what you might expect. Because when they specify how this fixture is as far as its intensity is concerned, this fixture is much wider than a fixture that you might see that the specification says it's brighter because all the light is narrow. But if you're going to put a lens or diffusion on that light that's narrow that you think is brighter and make it this wide, it may not be as bright. Does that make sense? Right? So you want to keep all these things in mind, and we're going to talk about that later. All right. So we have this running joke around the office here that Chris and I, if you know Chris and I, a long time ago, both started using track spots. The track spot is an old light. This fixture was built by High-End Systems, which now happens to be a company that's owned by ETC. It's mostly just a coincidence, I suppose, that ETC bought High-End a few years ago. And this fixture here is kind of interesting. I like to play with them, one, because I know these fixtures really well, because I've been using them forever. But the other thing is that I think they're kind of neat because you can see what's going on inside the light. So this is kind of an aside, but this concept follows through with any other moving lights that we talk about. So going back to my simple console, this is a very, very simple moving light. This moving light if we take a look at it here, it has a, let me just do this. It has a mirror on the front of it for moving the light back and forth. And my channel 1 is pan, my channel 2 is tilt. And you can't really see that up there. Maybe it would be better if I actually turned it on. So if I bring up the intensity on the fixture, and then I open the strobe, then we can see that that light is moving back and forth. Okay? And then one of the channels here, channel 3, is the color wheel. So there is, if I'm standing over here, there is a wheel that is actually rotating. So 50% or 128 is red. 100% or 255 is pink. And anywhere in between there is a different color. Likewise, there is a gobo wheel, and the same thing happens. I switch between the gobos. And as I'm moving that fader, then the fixture gobo changes. The reason that I'm showing this tonight is that that exact same concept follows through. It doesn't matter if you're using a moving light that is 7 channels like this one, or if you're using a moving light that's 53 channels. All of those different things, basically it's the DMX values that are being translated to what color you're on, what gobo you're on, whether the gobo is rotating or not, what the intensity is, all of those same sorts of things. That is why we need different consoles than these. Because this console is not going to do very well if we have fixtures. I mean, 7 channels is too much. We've already discussed it. 6 channels is really too much when you're trying to do theater. Right? Does that make sense? Awesome. Okay, let's turn this off because it's noisy. And the people in the back are all happy because they don't like the light. I like the light. Okay, so one of the things I kind of glossed over there really quickly is that this fixture here, this Chauvet fixture, has multiple personalities or different ways that you can control it. So we currently have it set up, so we're controlling it in this 6-channel mode: dimmer, red, green, blue, white, strobe. We can also set it up so that it's just in 4-channel mode: red, green, blue, white. We lose the strobe. If we want to have strobing, then we have to do that as an effect on the console. If we go to the next level, then there's an 11-channel mode. 11-channel mode gives us dimmer, red, green, blue, white, color macros. I don't know what that does. I think it probably flashes between colors, maybe. I'm not sure. Color temperature, which gives, actually color macros probably gives us things like it's blue, it's purple, it's green, probably more like how the color wheel on this fixture works, okay, for quick snapping to things. Color temperature is exactly that, so it's different colors of white. They have it listed from 2800 up to 6500, so essentially from more amber to more blue. Strobe is strobe. Automatic programs will be, again, they've got things on here like color fade, 7-color snap, 18-color snap, sound activated, that sort of thing. These are usually things that are more used if you need to come up with quick programming really fast, which is interesting because it takes more channels, but it's easier to program if you're trying to do things quickly, if that makes sense. We hardly ever run a fixture like this in this mode, because we typically will use either the 4-channel mode or the 6-channel mode and use the console to create the effect that we're looking for. Okay? We just talked about the track spot. So the track spot channels are pan, tilt, color wheel, gobo wheel, shutter, dimmer, and motor speed. And I kind of brushed over the motor speed thing. It doesn't really matter so much these days, but motor speed is a function where if you were using a traditional console and you needed to control how fast the fixture moved from one channel or one position to another, older consoles, when this thing was created, older consoles didn't have the ability to to provide the timing that worked to make it go from this position to this one, so you could actually set it on the fixture. Most of the time today, we would just turn the speed up to 100% and let the console do the math for a crossfade. Okay? So that brings us to kind of a quick, we're going to do a little bit of a walkthrough of what these different fixtures are. And again, what we're going to be talking about from here on out is we're using the examples that are here from ETC, but these are examples of fixtures. There's lots of other brands that we work with that have similar sorts of lights. We just happen to be using these because we do a lot of work with ETC. We like these fixtures a lot. We like the company. We like their warranty. We like how they work. So I'm just going to kind of go through a couple of things that are kind of interesting about these. I'm going to unplug out of this console and stop using this old analog thing and jump over to here. And so let's see here. Actually, I am not going to start with that fixture. I'm going to start with this fixture. So this is a color source par. We own and sell quite a few color source pars. They're great. They have good color output. They have good light output. They're fairly bright. They are a par by name only. If you remember what a par 64 is, or a par 56 is, or maybe a par 36 or par 30, par 20, that's the size of the bulb from an old par can, or sometimes a recessed light in your basement or in your office or in your dentist office might be a par bulb that screws in there. This is called a par only because it's got a similar sort of usage in that it is a general wash light. Okay. These fixtures, first of all, I should say that they're fairly narrow. The light output of this is fairly narrow. That is normal for a par fixture. It doesn't matter if you're buying it from Elation or ETC or Chauvet or so many other brands. It's fairly narrow when it comes out, and that's partly because it's easier to make this wide than it is to make it narrower. By making it narrower, you're cutting out light. Besides that, when it's narrow, then the marketing department gets to say that it's really bright. Right? But this is a good light. You can, if you get close to it, you can hear the fan, but I'm sure that nobody out here can hear the fan. It's pretty quiet. This light, if we take a look at it here, I can change the color using the touch screen on this console, and I can change the color pretty quickly to be kind of whatever I want. This fixture is available in a couple of different versions. This is the standard version, and then they also have a version that they refer to as the deep blue color source par. And the deep blue has an indigo, a deeper indigo color in the blue. So if I bounce around, you can see that it's changing that red, green, and blue, and it's doing it by itself to figure out which colors. The console is figuring it out so that I don't have to be moving around the faders to try to guess what color I'm going to get to. Now there's an interesting twist to this fixture. This light, the DMX breakdown for this fixture is dimmer, red, green, blue, strobe. Very, very similar to the fixture beside it. But there's actually another light element in there, and it is a lime element. But in the current configuration, in the current fixture profile that we're using, that lime element is only brought in when the fixture thinks that that's what you're trying to do. So they've tried to make this simple for you so that when you say that you want white, it's going to put in the lime element to give you white when it thinks that you need it. And when it thinks that you're trying to do green, then it's going to bring in the lime element to try to help you get to there. Okay? You can run this fixture in direct mode. And then that will give you the ability to control all the colors individually if you want to, or if you want to just make sure that it's doing what you think it's supposed to be doing. Okay? So that's the color source par. Pretty simple. Going to bounce to this fixture. This is the color source spot junior. So if you know the ETC lineup of fixtures, you know that there is a source 4, and then there is the source 4 junior, which is like a source 4, only simpler. You lose some things like you can't change the lens tube, you can't rotate the barrel, you can only go up to a 575 watt bulb, you can't do 750. There's a couple of other things. The light output's not as good, the light output's not as bright, it doesn't have the glass reflector. It's not as good. This fixture is intended to be a simple solution for community theater and for schools and what's often referred to as black box spaces, which, kind of like the room we're in right now. And it's an all-in-one piece. I should say that the way that this fixture is right now, it doesn't have any accessory holder on the front, so you can't put diffusion or anything like that. Color, I don't know why you would, but you can't put color in front of this because it's missing that. You can buy that as an extra. They've intentionally made this fixture so that it is kind of a one piece. It's pretty inexpensive to purchase, relatively inexpensive to purchase. It is composite. That's the word I'm supposed to use. And it's very lightweight. And so it's great. So if you're carrying it up a ladder, that sort of thing, then it's good. It takes a different size of gobo than what you would see in a regular source 4. But it is a zoom fixture. So this is actually as tight as this fixture will go, but we can also zoom it out quite a ways like that. Obviously, as we're zooming it out, we're not changing the intensity of the fixture. What we're doing is we are spreading the light out further. But again, I've got shutters that I can bring in and shutter this down to where I want it. And then I can adjust that. And because the lensing is, again, not premium lensing, then you're going to get a pretty good shutter on that fixture. Is it as good as the traditional source 4? Nope, it's not. But this is a pretty good shutter. It looks pretty good. And again, I can zoom that. Let's zoom that in and adjust that. And you're going to find that at certain focal points, you have to adjust the two lenses together to kind of get it the way you want. Okay? This has a very similar light engine to the color source par. You'll note that this fixture actually gives me a deeper blue because this has the indigo blue in it rather than the standard blue. Okay? That's the color source spot junior. And we've had really good success with this with community theaters and with churches and different spaces. It's good. We like it a lot. And that brings us to this fixture, which I want to spend a couple of minutes on. So this light is the color source spot. And the color source spot is not a source 4. There is the source 4 LED, which we actually don't have one in here tonight. We have source 4 LED series 1 here, series 2 on the shelf, and series 3 if you want to take a look at how the differences are. This fixture is a fixture that sells for closer to, I want to say, with a lens, $2,000, something like that. Whereas the LED Series 3 is closer to $3,000. So it's kind of a different animal. We're going to talk about, I'm going to show you on kind of on the screen here, kind of what some of the differences are. But this fixture is kind of neat because it has a different light engine. You can see how much brighter it is than the other one. And it has actually got both the deep blue. This is a color source spot V, so the newer version of it. It has both the deep blue and the regular blue in it. So it's got an indigo and a standard blue. And so it can create a pretty good white, and you can tweak that a little bit depending on what you need to do, as well as it does everything that a regular Source 4 does. So you can do some interesting things, like you can take a gobo, throw a gobo in there of dinosaur, and that looks pretty good, right? This is just a quick thing. You notice the gobo goes in upside down because of exactly the same piece that we talked about way back, that an axial ellipsoidal fixture, that the light that's coming out of that is going to flip the image. So if I put it in like this with the dinosaur head pointing towards me over here, when I throw T-Rex in here, then T-Rex's head is over there and he's flipped back up the right way. On LED fixtures, this doesn't matter so much. What I mean by that is, if you put it in and it's an LED fixture, then you pull it back out again and you put it in the right way if you put it in the wrong way. When you do it into a Source 4 and you put it in there and you realize you put it in the wrong way and you pull it out, give yourself a minute or two. Otherwise, you end up with T-Rex in your thumb, which is not great. I've been there. Yeah, okay. As we're talking about gobos briefly, I do have a couple of other gobos that I think are kind of interesting and worth just taking a really quick look at. This is kind of a water wavy sort of a gobo that's interesting, and you can, as you change the focus on this, you can see that it does kind of interesting things. What's kind of cool about this is that I'm putting this gobo into the accessory slot, which means I can have a T-Rex that is striped. Although because of the waviness of it, I guess he's actually not going to be that distinct. But you can stack gobos. And another gobo that's kind of interesting that we have kicking around here is this one. Is this going to go in here? Here we go. So there's all kinds of interesting gobos that you can get your hands on, do some neat stuff with. Okay? And you can get custom gobos and so on and so forth. One of the things to keep in mind about these different fixtures is that a color source spot and many of the other fixtures out there from other brands that have similar fixtures like this, they are all based on that light. I can't overstate how that thing changed the industry. It doesn't matter if you go and look at a fixture from Chauvet, ProLights, Elation, etc., etc., etc. They are all made so that they look kind of like that, and they take the same gobo holders and all that kind of thing. Okay? What else do I need to show you about this? There's one other thing I'm going to show you about this. So that's what the inside of this fixture looks like. So the lensing is doing all the work to take each one of those different colors and spread it out so that it's an even light. And so if it's white, you can see that, so when I'm in the center here and I'm looking for a white, you can see that it's pretty much dropped out that one blue. But as I move towards red, as I move towards purple or magenta, blue, you can see that things shift. You can see it just quickly bounces through different colors as I move through. So there's a lot of math that's going on to make this happen. Okay? It's pretty cool. Any questions? Anybody? No? Mark wants to throw the catch box at somebody. All right. So that is the color source spot V. Many of the things that I just mentioned follow through whether you're looking at the Spot V or you're looking at one of the other fixtures out there in the industry that's of a similar sort of ilk. Okay. The newest addition to this line is actually a color source Spot V that is outdoor rated, so that you can take it outside and you can put it on a post out in front of your theater or something of the sort.
So your light, you can order different lenses for different
Yeah, that's a good question, Peter. So yes, you can order different lenses for different applications. So this lens right here is actually a 36-degree lens that is on the traditional Source 4, and this lens is a 19, but you can put different ones in. That's going to have an impact on the beam spread. Or this fixture has a zoom in it. We have zoom lenses that can go on this as well. So within the last couple of weeks, the folks at Drayton Entertainment, which is, of course, that's St. Jacobs and Penetanguishing and all of those different spaces, they purchased a number of this fixture, and they purchased them with zoom lenses because a lot of their rig can end up moving between different spaces, and so this gives them the ability to have fixtures that would work in many different applications. Okay, a zoom lens is, because of the versatility and because of what goes into it, more expensive traditionally than a regular fixture. Okay, or a regular lens. So lastly, let's talk about this one before we move on to other things. And this is the Color Source Spot V, Color Source Fresnel V, or V Fresnel V. And on this fixture, I can, again, change things. It is basically the same light engine as the one beside it. But one of the things that's kind of interesting about this is that although it doesn't look like a traditional Fresnel, it acts like a traditional Fresnel. And it gives us the ability to use the barn door to do some pretty good shaping of the light. Okay? Now, I was talking to community theater lighting designers recently, and we were talking about this fixture, and they brought up a really interesting point. And that is that this fixture is good, but if you oh, there we go. If you zoom it in and out, which is on this fixture a mechanical zoom, you can see that. Maybe I should pick a better color. Do you think I should pick a better color? As we zoom that in and out, it does zoom in, but it does not zoom in as tight as a traditional 6-inch Fresnel by any stretch. So there are some people who are going to look at that and say, that's just not what I'm looking for because it doesn't get quite as tight. But it's a pretty cool fixture. And the fact that you can adjust the zoom from the console has got some interesting applications. Now, understanding that, you can adjust the zoom, but you can't adjust the focus, you can't adjust the barn doors. You can adjust the zoom and the intensity and the color. Okay? It's a step. Okay? So again, we refer to this as a Fresnel, but the truth is that there is no Fresnel lens. It's mostly that it works like a Fresnel. All right? Any questions about that? All right. Okay. So let's get back on track here. So the next piece of discussion here is photometrics. When you start looking at lights, one of the things that comes up, I have already mentioned that looking at things like wattages for LED is somewhat subjective. It doesn't necessarily mean anything. And often, unfortunately, and no offense to Sam who takes care of our marketing here, but sometimes the marketing department will grab onto one thing and that's what they're going to run with. And that is, the wattage is not important at all for these fixtures. What's important is how much output you're getting out of it. And whether you are judging that by lumens or foot candles or lux, that's what's most important as to what's coming out. Now, you do need to make sure that you're talking about the same thing. I really, really like how Chauvet does their photometrics information. they have done a fantastic job of showing how these fixtures light works. Better than most manufacturers, for sure. So this is a Chauvet Ovation E910FC. FC stands for full color. E stands for ellipsoidal. 910 stands for something I don't know. I'm not sure what that means. But you can see there that they are saying that a 26-degree lens is going to give you approximately 25.5 degree beam spread. That's great. Sounds like they're being honest by saying that it's not just 26 degrees. And you can see that they've got some interesting information in here, and specifically, I'm looking at this, the spectral distribution is kind of interesting, because what they're showing here is where the LEDs are actually outputting relative to each other. Now you will notice, and we're going to talk about a couple of more of these in a minute, but you will notice that they don't give you any chart down the side to tell you exactly how bright that is. It's all relative to each other. So they're giving you an idea as to you've got more blue, more red, and that means that in theory we can create colors in these areas within reason. Does that make sense? Okay? This is going to make more sense in a minute, I think. So then, if we're taking a look at the output of this fixture, first of all, the fixture manufacturer says that this fixture is approximately 4,316 lumens for its output. Okay? And if we take a quick look at it, if we are looking in metric, then at 3 meters is a good number. So 3 meters are approximately 10 feet. We're at 3,938 lux at 3 meters. Okay? And if we're talking about foot candles at 10 feet, then we are looking at about 366 foot candles for this fixture with a 26-degree lens tube. Okay? Now, unless you walk around with a light meter all the time, those numbers might not mean anything. So, but what's more important is typically if you're comparing them between things. So if you're comparing it to what your fixture that you're using right now is, or if you're comparing it to another fixture that you're thinking about purchasing instead. Now, I am showing you these two fixtures side by side in a second because I need something to compare. I'm not saying that these are competing fixtures, but these are the two I grabbed just because it was easy. And I might get a phone call from our Chauvet rep to say, why did you do that? I'm building up to something here, though. The color source spot V, this guy right here, this is with a 26-degree lens tube. The throw distance of 10 feet gives us 585 foot candles or 6,292 lux. Okay? So that we're talking about those side by side, because of course it's a lot easier when you see them side by side. I know it is smaller. That means that we are looking at a lux on the Ovation of 3939 versus a lux of 6292. So a fixture that looks the same and has a similar sort of lens is not necessarily going to have the same output. Okay? Now, there's an interesting piece to this puzzle, though. And that is that both of these fixtures, those output numbers, and you can see there's the other numbers there for at 10 meters or 30 feet. Both of those fixtures, the manufacturers are telling you what the output is at full color. Nobody ever runs the fixture at that because it's gross, because you get that kind of purpley color. And it's not being really fair or honest. And so if you want to know what the fixture output really is, because if you look at that and say, wow, look at that, that color source spot V is super bright compared to my source 4, and my source 4 is creating this, Now, we're an ETC dealer, so I got to be careful about how I say this, but sometimes the marketing department gets a little bit loosey-goosey with this kind of stuff. So if we go and take a look at this fixture, first of all, that lumens of 9,498 lumens, that's not at 3200 Kelvin. So you can't use that as a comparison against a regular source 4, because that's all of the light elements at 100%. When I was moving through here and we were looking at that fixture and you saw the light, the LEDs change, they never all went on, not at white. So that's not actually the main output compared to that. I am not saying you shouldn't buy this fixture. I'm saying just make sure that you understand what you're reading when you read the paperwork. So if we take a look at this and we look specifically at the photometrics information, which is not hidden, you can find this, you just have to look for the right thing. If you look at the photometrics information for 3200 Kelvin, which would be that white look. So let's go back to this for a second. That was this light. This is going to be at approximately 3200 Kelvin. In fact, no, I can't just bounce to that on this, can I? Gels, clear. Yeah, so that's going to be at approximately 3200 Kelvin. Now this is the actual lumens that it's providing at this with a 26 degree lens, with these different lens tubes. And this is super, super interesting information. A 5 degree lens tube, so it's very, very narrow, is 4842. 10 degrees, 5432. If you jump down 26 degrees, is 5809. 26 degree EDLT, and we're going to talk about what an EDLT lens is in a second, but that is their high definition lens tube. That is a significant jump up to 6900. So that same fixture, depending on which lens you're using, is going to have a very, very different output. And so if you're looking at that fixture and you're saying, well, the spec sheet says that I'm going to get 6900 lumens out of this fixture, but you're going to be using a long throw lens, you just need to keep that in mind as you're using the fixture. Does that make sense?
No.
No? Why?
Well, up there you've got a 5 degree lens.
Yep.
At 4800 lumens.
Yep.
And then a 50 degree lens, which is way wider.
Yep.
At 6500.
Yep.
Why?
Because the 5 degree lens is plastic and it's inefficient. And
that's it.
and the way that the light is getting to that 5 degree lens. So Bob, have you seen one of the 5 degree lens tubes?
I haven't. No.
So a 5 degree lens tube for one of these fixtures is about this big around.
Okay.
And it's out this far. And so how it's collecting the light and how it's sending that out, that's the difference.
Oh, okay.
Mm-hmm.
Okay.
I know, it doesn't make sense.
Yeah.
And it doesn't make sense that the 26 degree is the sweet spot and then it's the brightest.
Yeah.
But that's the numbers. These are the numbers right off of their paperwork.
Huh.
It's pretty interesting. Compared to the column to the right, which is direct mode full on. And again, I get it, because on one side, if all the other manufacturers are quoting their numbers at direct mode full on, well, then I guess you have to quote that, right? Then I guess ETC has to be comparative and say, well, yeah, okay, if we're comparing that gross color that nobody ever wants to use and doesn't care, well, then, yeah, I guess we'll show you that number. But if you dig a little bit, then you can get the numbers at 3200 Kelvin or at 4000 Kelvin if that's what you're looking for. And you can see some numbers that are a little bit more reasonable. Okay? Is that interesting?
Yeah.
Kinda, sorta? So, I mentioned EDLT. We actually, in rentals now, pretty much only have EDLT lens tubes. You can tell an EDLT lens tube pretty easily from a distance, and this is an ETC thing. It's the numbers on the side of it are in blue on these fixtures. Oh, well, actually, we'll come back to that in a second. Logan just said except for the 50 degree. Do we actually have standard 50 degrees, or do we have Or are all of our 50 degrees now 50-degree LED lens tubes? We have both? Okay, great. So a standard source 4 is the one on the left-hand side, and I'm not sure if this is going to read really well for you in here, but the one on the right-hand side is a source 4 with an EDLT lens tube. The EDLT lens tube is an enhanced definition lens tube, and it is using a different configuration of lenses, and it's using different lensing, and it changes it that much. And so I'm not sure if you can see that so much. And this, of course, is their rendering from their website, so it's maybe, it's kind of an artist interpretation of what the difference is. But it gives us the ability to have T-Rex be really sharp, whereas if we showed you what a traditional lens looks like, it's not as sharp. So why does that matter? Well, most of the LED information that's out there is using the best lens tube that any manufacturer makes. So specifically when it comes to ETC, they're going to show you what the best lens tube is. Again, I will 9 times out of 10, I will sell you an ETC fixture over the other ones. And part of that is because I think that they're honest about what their information is. But again, you need to be sure what you're looking for. Okay? All right. So let's talk about this for a second. I think this is kind of an interesting thing. These are screenshots from the ETC EOS software. EOS is a software that is used on everything from a laptop up to the lighting consoles that are running stages at Stratford. Okay? And it scales. So a laptop version is easy to use in that it's nice and simple. It's down to one screen unless you plug in other things. But then you can scale that up and you can add on a fader wing and you can add on a programming wing and so on and so forth. And once you get up to the Apex consoles, then it's got big touch screens and other encoder wings and stuff. It's awesome. What's cool about this is that ETC knows their fixtures because they build them and because they build the console, and they're able to show you what each of these fixtures will actually do on a color spectrum. So what they're doing here is they are closing in this, and this line around the outside is intended to give you a bit of an idea as to how much of the color space you are going to be able to reproduce using that fixture. So when you click out here, it actually moves it to here, so that it gives you an idea as to what that color is. The theory being that if you selected all of these 3 fixtures together and you clicked in here, you should be able to get all of those 3 fixtures to be in approximately the same color. But if I click outside of here, I might be able to do it with this fixture, might be able to do it with this fixture, but I can't do it with the source forward color. Does that make sense? So this is interesting information because ETC has been very good about, specifically with their fixtures. I can't tell you that it is always going to be 100% accurate with other manufacturers because they're trying to kind of guesstimate how these other fixtures are going to react, but they don't necessarily know what shade of red and what shade of blue each of those other fixtures are from different manufacturers. But this is an interesting thing to kind of just give you an example of how this can change and how this can be different between different manufacturers. So when somebody says, well, my fixture is a red, green, blue, white fixture, that may mean one thing or it might mean a different thing, depending on what the levels of each of those are. Further to that, let's take a look at this. So this is the color source spot V, this fixture, with a source forward MK2 white. Does everybody know what a source forward is? If I take this fixture here and I take the burner assembly off the back end of this fixture, I can put an LED on the back end of it for $850, $800, something like that, and it becomes an LED light. And there's 2 different versions of this that are sold most regularly right now. One is white and one is color. And we we could show you both. We don't have one up here tonight, but we can show you one later if you'd like to see one. And it fits onto the back end of the light here. So this one that's in the middle is a white version. So it's actually using a couple of different LEDs to create white. And the theory is that LED is going to give you a white that is going to be close to 3000 Kelvin. That's the goal. Okay? And then this is the color source par. So again, I want to make sure that we're on the same page here. It's difficult to compare these exactly because of the fact that there is no value up the side of the chart to tell you is this red the same intensity as this red. You really need to just compare these LEDs to these LEDs and these LEDs to these LEDs. Does that make sense? But what's really interesting is that you can see that on each of these fixtures, there are more or less amounts of brightness. Brightness, is that the right word? We're going to say brightness. There's more output at each of those different areas created by the LEDs that are within the fixture to be able to get the colors that you're trying to create. But it also means that there are some colors that you're not going to be able to create as well. And you might be wondering, why is it that I can't get that color? Like, if you're looking at the color source spot V, why is it that right here, these colors in here, I can't create the same way as I can some of these colors or some of these colors? And this is an interesting piece to be able to help you kind of compare how these different fixtures will work. Does that make sense? Again, it's a tool, but it doesn't necessarily tell you the whole story when you can't see how it compares between this fixture and this fixture as much. I thought that this was an interesting one. This is the source for LED 3. So now we go from a fixture that has 5 colors: indigo, blue, green, lime, and red, to a fixture that has indigo, blue, cyan, green, lime, amber, red, and deep red. And with all of those different colors, you see how much flatter this is, with the exception of this guy. How much flatter this is? In theory, you're going to get a much more even ability to create color. Does that make sense? One of the things that's often argued with LED fixtures is the ability to not get good red. That's why everybody is spiking, or well, ETC in this case, is spiking their red to be able to get good reds, because the blues just come through so much more intense. You've got that look on your face, Mr. Hume.
Yeah, what would the upright value be? Like, what is it?
It's going to be the amount of output that's going to be for that color.
Oh, okay.
Yeah. But it's what they're saying is that you need that much more to be able to create the colors that you're looking for. And if you take a look at this fixture here, and you put it side by side with the LED 3, which we didn't do tonight because we only so much pipe and such. We could keep adding more fixtures. And you look at the two side by side, the reds that you can get to with the Series 3 are incredibly different than what you can get to with this fixture. And unfortunately, it's one of those things where sometimes it's better not to compare, because you can be really, really happy with this until you compare it to this. You can be super happy with this until you compare it to, you know what I mean? It depends. But what will happen is that when you start talking to scenic artists, or you start talking to wardrobe, and they're looking at a costume and they're saying, it just looks gray. It doesn't have that pop. There's something about it. It's just not popping. That's what it is. It's because you're not creating that full color spectrum. You're not filling it in. And then this one is kind of an interesting one. Remember I said that the color source par was available in a standard and then a version that is deep blue. So the one on the left is the deep blue with the indigo LED, and the one on the right is the standard fixture. And so you have to have a lot more of that indigo blue to be able to get that output. It's pretty interesting. So we've covered all kinds of things. We've been all over the place tonight. I hope that helps a little bit. What have I missed? What more do you want to talk about tonight?
So the output levels for, let's say, more red, are there more red LED bulbs, or is it in the software that drives the LED bulb?
Right. So the question is, if when it shows that there's more red, does that mean that there's more LED bulbs? Yes or no. It depends on the manufacturer. Some manufacturers, if you look at their spec sheets, I'm thinking, actually, I think that Ovation fixture, I think it's the Ovation fixture, but I've looked at a lot of fixtures. I look at a lot of fixtures all the time. But some of the fixtures will tell you that it has this number of red elements and this number of blue elements and this number of green. But then other fixtures, it'll be the intensity of that LED that they've put into the fixture. So a fixture like this, where you have 8 LEDs behind here of each of the colors, you don't have 2 reds behind this and 2 reds behind this and that kind of a thing. They would be brighter reds to be able to create that. Okay. And again, different manufacturers have different philosophies on how this works. And some manufacturers, like ETC was the first one to introduce the idea of introducing a lime color. And some manufacturers call that a mint color. But that idea was trying to come up with a way of not having 8 colors or 7 colors like they do in the Source 4 LED 2 or the Source 4 LED 3, 7 and 8, but trying to do it with less LEDs. 4, using the lime helps to be able to get better skin tones and that sort of thing. Okay. Any other questions? Nothing? All right. Well, thanks for coming tonight. And if you've got any questions, or you come up with any questions that you want to talk about later, then certainly we can do that. If you've got questions about things like control, then we can talk about that. This sort of topic can kind of just keep going and going and going, and we can talk for a long, long time. I do want to mention the next Resource Stage seminars, and for those of you who've come to seminars here regularly or watch online, you'll know that in the last year or so, I've been terrible at doing this, and that is actually remembering to put up a slide of what the next seminar is. So I'm trying to get better. So next month, on Tuesday, April 9th, we will be hosting a seminar on digital audio mixers. This is a seminar that we do pretty regularly on an annual basis, but we also do lots of training on digital consoles for people in their schools and community theaters and churches pretty often. This one is actually going to be done by Don Clausen in our office and Logan. Don and Logan are going to work together on doing this one. They're going to talk about the Q and SQ series of consoles, and I think it'll be interesting. It's always good. It's good if you are somebody who's moving from analog to digital and you're wondering what the differences are and what does that look like, or if you're somebody who is a volunteer in your school or in your community theater or in your church and you're kind of nervous about what does this look like, or if you're looking at purchasing a new console and you're not sure what that looks like, you're moving from a Q to an SQ, then you can see some of the differences on that night. Okay? We have a tradition at Resource Stage at Horizon to be doing different things that aren't just seminars, and we are finally getting back to doing something that we did many, many years ago, and that is that we're going back to the Grand Theater to do a backstage tour on April the 20th. And we have done this many times. Sorry, not many times. We've done this a few times before, and it's great. It's a lot of fun. You get to kind of go all over the place at the theater. We take you around the lobbies, which everybody gets to see the lobbies, but there's some specific things that we can point out in the lobbies. And this is the newly renovated Grand. If you haven't been there in a couple of years, like say it's been there since COVID, then there's a lot of things that are going to look different. We're also going backstage. We're going to, if the timing works out, to the pit to take a look at that. And we're also planning on going up to the fly floor. So if you are interested in that, then that is a cool tour to take. 2 things to keep in mind, maybe a couple more than 2. One is that we can only take 20 people on this tour. 2, we can only, you're wanting to sign up right now, Ken? Okay, well, you can register online. And you can register, that's at resourcestage.ca. Yes, Sam says yes, resourcestage.ca, you can register there. So 20 people, register at resourcestage.ca, $20 to go to help us pay for some of the union staff that are going to be on staff that day to show us around a little bit and show us how that cool sound system works. And the other thing is that we're planning on going to the fly floor. So just be aware of that. If you're planning on coming, make sure you're wearing shoes that you can get up to the fly floor. And if you're not good with heights, you may want to consider if you want to come. Because you got to go. Okay, Bob says you got to go. It's a lot of fun. It is cool. But yeah, it's a great time. So if you can come, then that would be really, really good. So again, we have the digital audio mixer session on April the 9th, and then on April the 20th, which is a Saturday, then we are doing this tour. The tour, I want to say that the tour is starting at, Sam, do you remember, is our tour starting at 11 o'clock? 11 o'clock, thank you. So we're starting at 11. It's going to be about an hour and a half long. And then kind of an interesting thing or a unique thing is that there are actually 2 matinee shows going on at the Grand that day. One in the Spreet stage and one in the Auburn stage. So you can go to the tour, maybe grab some lunch, and then come back to a show. The $20 does not include your cost of the ticket for the show. So sorry about that. But definitely, if you get a chance, then you should go and check out the show, one of the 2 shows. Okay? Thank you very much. If you've got any questions, then please let us know. And as always, if we can help you out, then we're around to try to help you do that. Thanks for coming.